Welcome to Algebra 1, Unit 6, Lesson 6-4, Standard Form, Pearson, Algebra 1, copyright 2009. I'm Mr. Pilarski, and our objective today is I will be able to graph equations using intercepts. Some key word from this lesson, x-intercept, that's relatively new to you. You might have encountered that in pre-algebra. You probably did. Y-intercept we talked about in Lesson 6-2 when we talked about the slope-intercept form. That's the place where the linear equation crosses the y-axis, and today we're going to introduce the standard form of a linear equation. When you encounter the standard form of a linear equation, you're going to want to graph it using the intercepts. So first we're going to take a look at finding the intercepts. Actually, first we're going to take a look at defining the standard form of a linear equation. The standard form of a linear equation is ax plus by is equal to c, where a, b, c are integers, a is greater than 0, and a and b are not both 0. What all this means down here is that a, b, and c are going to be numbers. A is the coefficient of the x term, b will be a number being the coefficient of the y term, and c is the constant, and in standard form it's the constant that's on the right of the equal sign. A has to be greater than 0 to be in standard form. That means a cannot be negative. Since it's going to be an integer, we know it's not going to be, in fact, that makes it have to be a natural number. A and b cannot both be 0 at the same time. If a and b are both 0 at the same time, then we don't have an equation, we just have a point. This bit gets us into graphing, or talks about graphing. You can use the x and y intercepts to make a graph. The x-intercept is the x-coordinate of the point where the line crosses the x-axis. Just like the y-intercept, the linear equation is going to cross the x-axis, unless of course it's horizontal line, and we'll talk about that in example 5. Let's look at finding the x and y intercepts. Example 1t, finding x and y intercepts. Find the x and y intercepts of the following equations. Now, a good friend of mine and colleague, Mr. Holler, who teaches 8th grade Algebra 1 and pre-algebra, likes to call this the 0-0 method, because what we're going to be doing is substituting 0 in for x and 0 in for y. I'll refer to it either as the 0-0 method or finding x and y intercepts. So to find the x and the y intercept, we're going to substitute first x, we're going to substitute in 0. Now what that's going to give us is the y-intercept. So we take the original equation, 3x minus 5y is equal to 9, and we substitute 0 in for x. That gives 3 times 0 minus 5y equal to 9. This term becomes 0 because 3 times 0 is 0, and 0 take away 5y is negative 5y. So on the left of the equation, after we simplify, we have negative 5y. We bring down the rest of the equation, that equals 9. Next, we divide each side by negative 5. And we get y is equal to the fraction negative 9/5. So that's finding the y-intercept. This is the y-intercept. So we need to find the x-intercept now. And to find the x-intercept, we're going to substitute 0 in for y. I label my work just saying, hey, I'm making y equal to 0. So I take the original equation again, and in for y, I'm going to substitute the 0. Much like in the first part of the example, the minus 5 times 0 becomes 0, and 3x take away 0 leaves us 3x. So when we simplify, we're left with the x term in this case being equal to 9. Divide each side by 3. X is equal to 3, because 9 divided by 3 is 3. So our two answers in this case, the y-intercept being negative 9/5 and the x-intercept being 3. Moving on to part B, it's a similar type of problem. First, we're going to find the y-intercept, so we're going to set x equal to 0. taking the original equation, substituting 0 in for x, 2 times 0 plus 5y is equal to 6. The 2 times 0 becomes 0, and then we add that to 5y. That leaves 5y on the left, being equal to 6. We divide each side by 5. 5's on the left cancel, leaving us y being equal to 6 over 5. So that would be our y-intercept. We move on to find the x-intercept, so we set 0, y equal to 0, taking the original equation again, substituting 0 in for y. That'll give us 2x plus 5 times 0 is equal to 6. 5 times 0 is 0, leaving us with 2x on the left of the equation. On the right, we have 6. Divide each side by 2, giving us x is equal to 3. And so our x-intercept is x is equal to 3. So both of these equations share the same x-intercept. To kind of summarize what's going on here, to find x and y intercepts, you substitute 0 in for x to find the y-intercept, and substitute 0 in for y to find the x-intercept. It's really just 2 steps. Now we're going to see how we're going to use these intercepts to graph an equation. Example 2t, graphing lines using intercepts, or graphing lines using the 0, 0 method. The reason you're going to want to use the 0, 0 method, or using intercepts here, is because this equation, 3x plus 5y is equal to 15, is in the standard form of a linear equation. And to find the x and the y, well, we're going to find the x and the y intercepts, then we're going to plot them on the graph. So we're going to first set x equal to 0, as we did in example 1. Take the equation that we're given, 3x plus 5y is equal to 15, and substitute 0 in for x. So that'll give us 3 times 0 plus 5y is equal to 15. This side, we've seen it twice already. The 3 times 0 goes away, leaving us 5y on the left, or the y term anyway. Dividing each side by 5 to get rid of this 5 in front of the y. And simplifying, this 15 divided by 5 gives us 3. So our y-intercept, where it crosses the y-axis, is a positive 3. So up 1, 2, 3 from the origin. Then we find the y-intercept. We find the x-intercept by setting y equal to 0. So we take the original equation and we substitute 0 in for y. That'll give us 3x plus 5 times 0 equal to 15. 5 times 0 becomes 0. Add that to 3x. That gives us 3x. And the equation simplifies to 3x is equal to 15. Divide each side by 3 to get rid of this coefficient. The 3's divide out, giving us 1x being equal to 5. So our x-intercept is 5. So starting at the origin, it's 5 to the right. 1, 2, 3, 4, 5. We have 2 points. And by geometric definition, that is good enough to graph a straight line. So we draw a straight line through it. And we could find out other things from that now that we know 2 points on the line. We could find out the slope of the line. And we already know the y-intercept, so we could easily write it into slope-intercept form if we wanted to. Let's move on to 2 special equations to graph that are in standard form. Graphing horizontal and vertical lines. Though you may not think it, this equation is in the standard form. The definition of the standard form, remember, is ax plus by is equal to c, where a and b both cannot be 0. So we need to think about what happens. If x is equal to 0, the x term goes away, leaving us by is equal to c. And in this case, the b is 1, so we have this equation y is equal to 4. Well, the question is, where is y equal to 4? Well, y is equal to 4. If you think about starting at the origin, it's up 4. 1, 2, 3, 4. It's equal to 4 there. But not only is it equal to 4 there, y is also equal to 4 over here. It's equal to 4 over here. This whole line, this whole horizontal line, represents where y is equal to 4. So when you encounter equations that are in the form y is equal to a number, in this case y is equal to 4, you know you're going to have a horizontal line. All equations that go y equals a number are horizontal lines. You should say that a few times. All lines that are y equals a number are horizontal lines. All lines that are all lines that are in the form y is equal to 4 are horizontal lines. Or all equations that are in the form y is equal to 4 are horizontal lines. That's a fact you need to learn and you need to remember. You could figure it out, but if you just learn to and memorize it and learn that fact, it's a lot quicker and a lot easier when you need to make graphs. In this case here, if we're talking about x is equal to negative 3, thinking about where is x equal to negative 3? Well, it's equal to negative 3, 3 places to the left of the origin. So here, but as we did with the horizontal line, not only is x equal to negative 3 here, it's equal to negative 3 here, it's equal to negative 3 here, it's equal to negative 3 everywhere along that vertical line. So when you have an equation in the form x is equal to a number, it gives a vertical line. This is also in standard form. When we're thinking about it up here, these y would be 0, leaving us with only the x term. This has been Mr. Pilarski with graphing equations in standard form of a linear equation. Thanks for watching. Bye-bye.